Good morning. I'm Ramkumar, and this is a presentation about how to go about troubleshooting problems with your NSO. We'll take a look at all the logs that NSO has and what information each logs provide and how to look at those logs. That's the first step. And I'll go through each log in turn. The first one is the NCS log, which logs what the NSO is doing right now, or when it's starting up. It logs all the loading of FXS files, XML files, loading of packages, and starting of NCS, stopping, and so on. So I'll also tell you what situations each log is useful in, and when you run into this particular problem, you have you can look at this particular log and so on. So for example, I have a NCS running here in my machine, and if we take a look at the NCS log here, so we have things like loading FXS files and Java VM starting, and these are the loading of XML files that are in the load path. So everything that is done by NSO when starting up and while doing package reload and so on are logged in this log. Next is the developer log. This is one of the most important logs for troubleshooting issues with almost anything, because it logs all the different stages of the transactions, and it logs things about AAA and NACM rules. So if you want to see, like for example, if you face an error that the CDB is logged, you can look at the developer log to see who is holding the log currently. And there are three trace levels of developer log: error, info, and trace. You set it in the NCS conf. By default, it's set to info, and while debugging and while developing, it's recommended to set it to trace, because then you have more debug info so that you can know what's happening. But in production, it's suggested to set it to info, at least, so that you don't disable it completely, and the error level is too low priority. So let's look at the developer log and see what is logged in the developer log. So this is a system install. I'm running it in a Docker container in my machine. So this is when NCS was starting up for the first time. It says something about embedded apps in phases. So NCS starts in phases even if you don't explicitly ask it to start it in phases. And these are about loading the XML files in the load path. And this is, as I said, the developer log logs all the different stages of a transaction. And here, this is the init transaction, the so-called first transaction opened up by NSO when you start, so that you can attach to it and make additional modifications if you want to. And that is evident by this T handle here, which is -2. Usually, when you start a transaction yourself, the transaction handle will be a positive integer. So the only cases where it's a negative integer is during an upgrade transaction or an init transaction when NSO is starting up. So this way you can know that this is the transaction created by NSO while it's starting up. And we can see the phases of the transaction. So it's now in the validate phase, and it's grabbing the transaction log here. here it runs the validations and the hooks. And here it enters the write phase. This is where all the actual writes are done to the CDP. And after write start, it enters the prepare phase where if it has to talk to the devices, the actual commands are sent to the devices. And then in the commit phase, typically the devices are, the config sent to the devices are committed to main memory. These are the usual things in the devel log. And what other information you can get from this is transaction IDs, and these are all SNMP things. Let's go here. So here you see what these kind of messages are introduced newly, and here you can see exactly who is requesting a lock and for which device. So these messages are very useful for debugging lock-related issues. These debug printouts are not present in earlier versions. I think it was introduced in 4.4. So yeah, the developer log explains all the phases of a transaction, and it says what is being sent to which device. So here it says, after calculating southbound diffs, I'm now sending an edit config to the device P2 in the prepare phase. Before that, well, let's look at how to parse the developer log. Most of the logs are in more or less the same format. So here, first, starting with the trace level or log level, this can be one of these things depending on what you set in the developer log level in NCSConf. So if you set error, and only crit and error level logs are logged in the developer log. And if you set info, everything until info is logged. And if you set debug, everything is logged. So this is the first field is the log level, and the second field is the date, and then follows the host name, the host name of the machine in which NCS is running. And then this is the PID ID of the process in the Linux system. And this is the component that's doing the logging. It can take, these are the possible values. Here, devel C stands for client. So here, this is from the service call point. So devel C is used by things like action callbacks, validation points, service points, and so on. And devel CDB is the logs done by the CDB subsystem, and similarly for AAA and other systems. And this is the actual message. And next, we have the northbound logs. These are protocol-specific logs or interface-specific logs, like the netconf log or SNMP log, and WebUI-specific logs, and so on. So obviously, if you have any issue specific to some interface or some protocol, those logs are useful. And the audit log in general is a trail of events in the system. Let's look at the audit log, for example. So here, we can see all the CLI commands being executed by the user. And before that, here we see that the user admin is logged in and he's assigned to the group NCS admin. So all the CLI commands are logged here. But if you come through other interfaces like netconf or REST or something, you will only see that a user logged in, and then after the session is complete, the user logged out. because the actual REST payloads or netconf payloads are not logged in this log. The netconf payloads, for example, are logged in the netconf trace log. But this provides just information about who is logging in and logging out and who is doing what in the system. And next is the XPath trace log. This logs all the XPath evaluations done by NSO. XPath evaluations are done for a lot of things, so they are always going on in NSO. So whenever there's a must expression or a when expression in Yang models, or whenever you refer a leaf ref, NSO has to check the valid values for the leaf refs. So those are all logged in the XPath trace log. It's very useful for evaluating validation failures and transaction performances. If a commit is taking very long time, you can almost be sure that it's because of XPath evaluations, or at least it's one of the big errors, big cause for huge delays in transaction performance. But you need to use it with caution because it will slow NSO down. So when you're debugging, it's very useful to turn it on, but in the production, it's advised to turn it off. And then we have the error log. The error log contains the internal logs from NSO. It's useful for debugging the problems with NSO itself. If there is an error happening inside NSO, for example, an internal process crashes or something, the information will be logged in the error log. It's not a text file, it's a binary file. So it can be read by this command, ncs --print log, and then the error log. The NCS man page says that it's turned off by default, but it's always good to have it enabled. And you can always limit the size taken by the error log by, it's a wrap log file, so you can specify the maximum size that the error log takes. So you won't run out of disk space or any issues like that. So I don't see any reason to have this disabled, even in a production system. Because it's, when the other logs don't give you much information, maybe the error logs will give you what's actually happening inside the system. And then we have the Java VM logs. If you notice, all the logs prior to this were configured in the ncs.conf, but this is not configured in ncs.conf. It's part of the configuration data in the CDB. So you configure what class you need to log. So you give the class name here. Here I have used the MAPI class of the NCS zone API. But if you have your own service packages or your own components in the Java packages, you can give that component name here and set the level to whatever level you want to get the log messages from your own service package or your own Java component in the Java VM log. And of course, it's very useful to debug issues with your Java code in your packages. And if when you don't know what exactly is happening, it's also useful to log the internal methods of the NSO zone API, like comtailf MAPI, or if you use navu, comtailf navu, and so on. Yeah. And then there's the southbound logs, which is the logs of the communication between NSO and the devices to the south. the format of these logs differ based on what kind of device it is. If it's a netconf device, for example, the log is just a collection of netconf RPCs in XML. But if it's a CLI device, it's the actual CLI commands being sent to the device from the NED. So the point of all these logs is that we need to narrow down where the problem is, whether it's in NSO itself or between NSO and the device. And if it is in NSO, is it netconf specific or REST specific, or if it is a general problem for all. So when you're able to narrow it down, then we can proceed much more confidently. For example, this is the CLI NED trace of the Cisco iOS NED when we do a dry run. So the way to interpret the NED traces is by these highlighted words. It's the API of the NED. So first the NED connects to the device, and then it checks if the session is alive, and then it does prepare dry and sends the CLI commands. Earlier, what happened was there was no prepare dry API. Instead, we used the prepare API to send the commands to the device, and then we used to do an abort so that the transaction didn't actually go through. But nowadays, in later versions, we have a separate API for doing the dry run in the NED. And this, for example, is the commit. In commit, one more extra step is needed because we first have to calculate the current transaction ID to see if you are in sync with the device or not. And this, of course, depends on whether you have out of sync commit behavior to be accept or reject. I mean, you can go ahead and commit to the device without caring about whether you are in sync or not. But in this case, we do care about that. So the first step is to, after connecting, the first step is to initialize the session so that you, depending on how you calculate the transaction ID, you initialize the session by getting the current transaction ID. Usually that's done by, yeah, question? Mm-hmm. Yeah, we don't have to do that now, but earlier it was necessary because we needed the capabilities of the device. So we connected to the device to get the capabilities, and then we can calculate the southbound diffs. But now now you can populate the capabilities in the NSO CDP yourself as operational data. And if you do that, there is no need to connect to the actual device. Yeah, so you can bring up a device and do dry run towards that device without actually talking to the device.
It wasn't used for the actual conversion, just to get a capability.
Yeah, no commands were actually sent to the device because the conversion from the internal format to the CLI format is done by the CLI engine in NSO, so it doesn't talk to the device. So the only reason was to get the capabilities. Yeah. And this is a nice script that's shipped with NSO that collects all the log files. And you can optionally also specify a CDP backup and debug dumps and so on. So that it's very easy to use this to collect all of the information that might possibly be required to share with the tag teams or support teams. It only works in system install because it depends on the environment variables like NCS logdir and NCS configdir and so on. I'll just demonstrate how you can do that. So this is system install. So this is a script, and first, can you see it? Is the screen visible? Yep. Okay. So here it asks, describe the symptoms and what did you do, what did you see. So it's just a description for the problem for the attack teams. So let's say something. And now it copies the log files and generates, well, right now I didn't ask it to generate debug dumps, but it's just normal logging. So let's see what is inside this thing. So it has the description and all the files from etc NCS, which is the current config, and all the files from log NCS. But then let's remove this and full debug dump. So if you do this, oops, no, debug dumps. So now it takes a CDP backup. So it tars up the CDB files, and then it generates the debug dump, and then it tars the result. So now we have, in addition to the log and the config, we also have the debug dump and the CDB backup. So this is a very handy way to provide all the logs to the support teams. Only works in a system install though. Yeah. So now we go to look about some tools for debugging NSO. The first is NCS status. This is a command that gives you a lot of information about the current status of the NSO daemon. So let's look at what is present in NCS status. So it has the version and whether it supports concurrency or not. And I haven't enabled HA here, but if HA is enabled, you will also have the HA status here, and the daemon status is started. And if you do NCS status before NCS is fully started, it will be in phase 1 or phase 0, or depending on where it is. And then you have all the namespaces loaded in the system. And then you have information about the data models. So you have the module name, the revision, namespace and prefix, and what interface it's exposed to. And after this, you have all the loaded packages and their version. So I have these neds, and this is from the MPLS VPN example. And then you have all the currently active user sessions, and there is no user session active now, but there are a lot of system sessions. System sessions are internal sessions used by NSO. And you also have information about what transactions are active and what logs are being set. So right now we have one read transaction, but it doesn't hold any logs. And if a client is holding a log, you will see here that what log it's holding, if it's a write log or a read log or a subscription log, and so on. And then we have all the registered call points, validation points, action points, and service points. Here you can have something like some ID and then daemon name is unknown, that means that you have a call point or a validation point defined in a Yang model, but no client registered for that call point. And you can also have it the other way around, where you have the ID to be unknown, but with some daemon. That means that some daemon registered for a call point, but no Yang model is loaded where that call point is defined. So depending on what you see here, the problem might be different. So if you see the daemon name to be unknown, that might mean that the Java VM is malfunctioning or the Java packages are not initialized or something like that. Or depending on how you have implemented, if it's a Python package, then the Python VM is problematic. And if it's the other way around and some daemon is registered for a call point, but it's not present, and if the ID is unknown, that means that the Yang model is not loaded properly. And you can look at the NCS log to see if all the models are loaded properly or not, relevant to that call point. These are internal type points implemented by NSO. And if you have your own type points, that will be visible here as well. And what are the currently active partial logs and some information about the CDB files. And this is the current transaction ID in CDB in NSO. And then you have all the registered CDB clients. These will mostly be subscribers. And if these subscribers are holding a subscription lock, or if they are waiting for syncing of the subscriptions, those will also be visible here. So you can quickly see which subscriber is holding up the CDB or which subscriber is pending sync notifications. So NCS status is a very useful tool to see the overall status of NSO. And then we have Debug Dump. The Debug Dump captures the internal state of NSO. The actual contents of Debug Dump might not be very useful to people who are not very familiar with the internals of NSO, but the Debug Dump also contains very important information about the current state of the host machine, like the top output or the amount of free memory or the open sessions, netstat output, and so on. So you take a debug dump using this command, ncs-debug dump, and then file name. And then you read the debug dump using ncs-show debug dump. Let's see how that looks. So here, let's do. So we have dbg.bin here. So here it says taken on this date and time, and the version, and these are the hashes of these FXS files. It's useful to verify that we have exactly the same version that we expect, so that it's possible to load patches in NCS. So this just helps to make sure that this is what we expect from normal release. And then we have the whole ncs.conf that the current daemon is running on. And then we have the values of the dynamic config. And these are the contents of the CDB. And here, for example, we have the date, uname, and disk status, and the top output at the current time, net stat, and so on. So these are very useful in determining whether you have problems in your machine running NSO, be it memory issues or file descriptor issues or whatever. And then we have the NCS status output here as well, the same output as below, as before. And then we also get things from the error log. And these are internals that are probably not in scope here. So a debug dump is also a very useful tool that has a lot of information, and it has all the other things like NCS status and the Linux host information and so on as well. And this is another tool which you can use to see what is the actual contents of the CDB. And you don't have to have NSO running for this. You just need the CDB files. And this is also helpful for looking whether you have some particular config you're interested in the CDB or not. Like if you have a CDB backup from some time ago, for example, and you need to look at what's actually in the CDB, instead of loading that and starting NSO with it and looking at it, you can just do NCS -- CDB debug dump and the path. So it looks like so you specify the directory in which the CDB files exist. So if you do this, then you see all the hashes of the namespace. And then, oops, yeah. So here, these are all what I have in the CDB right now under alarms, alarm. It's kind of a weird format, but if you can make sense of the paths, then you can see that under devices, auth groups, you have a default auth group, and under devices device, you have a device called C0 with these configs, and so on, C1 and everything. If you have services, for example, LTPN, yeah, so these are the topology config and QoS config and so on. So the whole CDB contents, including the operational data, will be available here. And then we have these utility commands that you can use to quickly see, quickly do things related to CDB and MAPI functions, for example. NCS load is a command that you can use to load and save config from and to NSO. You can specify the format of the config you want and whether you want to include operational data or not and so on. For example, you can do NCS load. You can see more about these things in the man pages. Oops. I didn't know why that didn't work, but this works, yeah. So these are the options, and the -F flag specifies what format you want the config on. For example, NCS load, P is for pretty printed XML. So let's see device 0. Yeah. So this gives everything under devices device in XML format. And if you want it in the C style, CLI. We'll do this. And that takes a lot longer because it has to convert it into the system CLI format. And similarly, with NCS command, you can do a lot of things. And these are the flags to specify where NCS is running if you are doing it from a different system, and you want to specify which user and which group you want to be, and so on. And the actual commands are these. So you can do, you can use the CDP API to get some values, or you can use the MAPI API to get some values, and so on. And you can do a lot of things like trigger subscriptions and subscribe to something, and a lot of things. So this, for example, starts a MAPI transaction, and this is for MAPI read transaction. The source code for NCS command and NCS load are available in the release. So you can also modify those and compile them again to further customize what these commands do. And then this is a very nice set of tools in the NSO CLI for debugging a lot of things. They are introduced as part of NSO 4.2, I think. Yeah. And you enable them from the operational mode, and then you use them from the configure mode. And the first one, for example, is time command. That tells you how long a command takes to run. So if you do so I set it to true, and time command. So if I run a command like this, for example, and I'm waiting in this prompt, and then after some time I abort it, and it says command executed in 7 seconds. And you can use this to time any operation, like an action or a sync from, or a commit dry run, or an actual commit, and so on. And it will tell you how much time passed for that command to be executed.
You can set, go back to the CLI. You can set the same on the session. So set session there too, so when you're developing, you don't have to set it up for mode every time.
Yeah.
No, in the config.
It's in config mode. Okay.
There you get the inputs.
And then you commit it.
So while developing, that you have it all.
Yeah, so you don't have to set it each time you go back and forth. Yeah, good. Thank you. And then we have XPath. You can use this to evaluate XPath expressions from a given context. So let's say, so you can either evaluate an XPath expression, or you can say that you can test whether a must statement passes, or whether a when statement passes, and so on. And you can specify what context you are running the expression from. You can just run XPath must device name equal to, let's say, all the devices here are in localhost, so this should return true. But then you can also do XPath context devices. So the container devices is your current context, and then you can do must device name equal to C0 slash address equal to this one, for example, will fail. This is again the same thing, but written in a different way, in a different context, so it's also true. And then you can evaluate expressions, xpath eval. This one, for example, will evaluate the expression and return to you all the available devices. And you can imagine constructing very complex XPath expressions. So this is very useful for making sure that you get your XPath expressions correct in your Yang models when you're developing service models and such. When you're writing must expressions, when expressions, it's a very handy tool to make sure that you get your expressions correct, and also to check how long it takes for your expressions to evaluate, for example. And then we have debug commands. These are pipe commands to the commit command, so you can run them as commit pipe debug something, or commit dry run pipe debug something. We'll go through some of them. So I have a service config in my CDB, so I'll load it now. What was it? Oops, it should be in the. So this is what is the config I have loaded. This is a service config, so when I commit it, it will push things to multiple devices. This is from the MPLS VPN example from the release. So let's do commit dry run. Oops. Okay. Okay. So now let's do debug template. So here you can see how the values for the template are calculated. So it starts from So it starts from the L3VPNP.xml, the template, and it sets the context node to be the top of the service and evaluates each expression in the template and goes on. So when you're developing a service model, this is very useful to see how your templates will be evaluated. And the same thing with the debug service will give you what the fast map operations will do in this case. So here, the service will first share create this under devices device config policy map. So the ref count is 1, and then it goes on to create a class list with the key class default. So everything that the service does in terms of fast map, be it shared set, shared create, and so on, will be shown by this. And if there is a warning, that means that you're doing something, the service is doing something which is not very safe in terms of fastmath. So here, the service sets the leaf list, and that's NSO says that it's unsafe because instead of doing a shared set, if you just do a set, it's not the same config element cannot be touched by multiple services. So in those cases, this debug service will also issue a warning so that you can know what is being done in your service. And I mean, you can use set instead of shared set if that's what you want and you mean it, but it's still nice to have these warnings so that you are explicitly aware of that. And the next one is debug XPath, and this will show you all the XPath evaluations being done on the service model, if you have any. So here it says evaluating XPath for these, and the expression is device name. So this is actually a leaf ref to the device name, this leaf. So the value of this leaf is CE1. So NSO checks if there is a device named CE1 actually in the CDB. And for all the leaf refs and for all the must expressions in your service model, this will be evaluated. And this is just the same thing that is logged in the XPath trace log, but only relevant to your service models. Yep. There is also debug kicker. I don't have a kicker in my service model right now, but if you have a kicker, you can use debug kicker to debug what nodes are kicked and what the kick actually does. So if you are having problems with a kicker working, you can use the debug kicker flag to see what exactly the kicker is doing. Yeah, these are the same things. And some miscellaneous things about debugging. In general, when you have an internal error, it means that there is not a proper error message for that scenario defined. So NSO just says internal error. So the actual cause of the error will be logged in the error log. So it's only the error log that you can look at in this case to actually know why that error happened. And if you cannot read the error log or if you cannot make sense of it, you can contact TAC or support teams with the error logs. In any case, when an internal error happens, it's always good to raise an issue and contact TAC so that at the very least we might change the error message from internal error to something more meaningful. And in other cases, maybe there is an actual bug that we need to fix also. And then lastly, from some system issues, memory issues are usually hard to debug. And when you have looked at all the logs and you haven't gotten very much information, it's probably a memory issue. And you can know that the memory is the problem, or memory is kind of related here by random restarts of NSO or random restarts of the Java VM and so on. It's of course hard to keep track of this because you want to monitor the system status using top or PS and so on. But when you have this kind of restarts or slow performance and nothing else is of use in the logs, you can look at the memory utilization. And then going forward, the way to monitor the memory usage is by taking regular debug dumps or regular top outputs, for example, and seeing that the memory usage does not spike too much. And things like out-of-memory killer might also be relevant here. If the NSO daemon or the Java VM consumes too much memory, and the out-of-memory killer is enabled in the distribution you're running, your NSO process or Java process might just get killed, and at least in that case, you get an entry in your syslog that out-of-memory killer killed this process and so on. But usually, the process just dies if there is no more memory to use. And the logs don't show very much unless, the logs show that at some point, suddenly NSO starts loading the files again and restarts, because there's a hard process monitoring NSO, so that if NSO dies, it will automatically be restarted. So that might be the only thing in your logs to hint that it's related to memory. And then the other issue is file descriptors. You might suspect that there's an issue with file descriptors if trying to connect to a device fails, or trying to open a log file fails or something. You can check the number of file descriptors allowed for this process by using ulimit, and you can increase them if necessary. And sometimes you get errors like no space, which is the Linux error code for no space available. But then I have seen issues where you get this no space error when you're starting up NCS, but the disk is not full. In those cases, maybe your inode table is full. So then you need to check up if you have free inodes. And if you don't have, you can check that by the df command with the -i flag. And if you don't have any free inodes, that might mean that some process is leaking file descriptors, or some process generating a lot of probably empty files. And it might be NSO, it might be some other process. You just need to look at what process is doing that. There have been bugs in NSO as well that leaked file descriptors. So you just need to see what those files are and who is generating them. And the LSOF utility is very useful to see what the open file descriptors are. You can look at all the open files in the system, or only for a particular process and so on. So, for example, you can do, if you just do LSOF, it will just list all the open files by all the processes. But if you want to see it specifically for NSO, you just have to get the PID of NSO first, and it's this one. So then you can do lsof-p and that process ID, and here we just have like a few hundred files, maybe a few tens. So, and this includes all the logs as well as the TCP sessions, because everything uses a file descriptor. So things like LSOF and netstat are also very helpful in dealing with this kind of file descriptor issues. And yeah, that's all I have from me. Any questions? Yeah. Mm-hmm. Mm-hmm. What is the error you see?
So you include that error when you do show package package.
Mm-hmm.
You will see syntax error in file input. So the reload operation will succeed, but the package is not usable because the file is not doing that. Any reason
It's hard to say without the exact error, but yeah, sure. Mhm.
Say, you were talking here before about NSO debugging, but what about service code? Say I would want to pause the service execution, the create code, or and step into that code. What would be your recommended way to do that? How are you, if you are doing this? Right now, I have the option to set up a block lines, right, in my
Mhm.
code, but ideally I want to step into the code. So what's your way of, what's your step? How do you do that?
I have used PDB to step into the debugger previously, but the thing you have to be careful about is timing, I guess. If you, I have tried it. I have tried that for actions and validation points and so on, but not for services. But I guess it should be the same. You can use PDB in your service code at some point, and but then the thing is you have to run Python from terminal. You cannot let NSO start the Python VM itself, because then you can step into the code because it's not running with the shell attached.
How are you doing this? Or you just keep on reexecuting, reloading the package, or you use
The PDB approach is not that user friendly. In my experience, of course, I haven't done too much of package development. I get tickets from customers saying this is the problem, and I try to reproduce the problem with my own packages and so on. So my experience would be different from yours probably, but I find that the logging method is more reliable usually. But if you want to run using PDB, you should set this. Let's see. So there is this run in terminal command that you enable, and give a terminal command like this is the default command xterm with some title, but you can use your own command. And if you do that, and then NCS starts the Java VM, it will start it in a new terminal. And then if your package has import PDB in it, you can step through that in that terminal. But without that, you cannot do that.
But this will still run it locally, right? This on the NSO server.
Yeah. Yeah.
It will also do what we could do with Java, when we can just bring the socket to another machine and then just do something like, SSH port forwarding.
Should be possible, but I haven't tried it. Any other question? Yes?
So, could you let me know what is the most typical problem of NSO system? So, how do I encounter?
The most common problems I encounter?
Yeah, so what is the most typical type of problem? How do I encounter for the NSO systems?
Most of the problems most of the tickets that come into our team are either about performance, that the service transactions are too slow, or the device commits are too slow, and so on, or they are about if you are using things like clustering and so on. There are a lot of tickets about I can do this in the device node but not in the service node, things like that. And those are, in some cases, that's because of a bug in NCS, but in other cases, It's because you're not supposed to do those things from the upper nodes. So it's kind of architectural things. Yeah. Okay, thank you.